Yeah, thank you for reminding me. Okay, we're recording. Okay, so we'll go through and start with this one, right? So we have our uh, we have our 2 points that they give us, right? And then there are shortcuts on this thing. Sorry, what did I do? It's gonna start mirroring things. What did I do? Oh, I just have to click it again. Sorry, new program. Okay, we have our 2 point elevations, so we know if we subtract one from the other, we know the distance in elevation, so that's what we'll do first. So we have 33.3 minus 28.5, right? So I'm not gonna use my brain.
Use your brain.
4.8, okay? So our DE for this, oops, probably I'm trying to say, our DE for between here is 4.8, okay? So we're going to take our slope formula, slope equals DE over length, or right? Yeah. And we know the length of this because it is at 1 to 20 scale. And if we have it printed out, which I know it's a problem, not everyone has printers, but if you guys can get it printed out somehow, it's really kind of required for a lot of these exercises. You're gonna have to take your scale ruler and find the side that says 30. I know it's backwards, and scale your box, which these are like, what is it? 40 feet. Oh, 20 scale. My bad. It says it up top. 20 scale. Measure it. Still not at 20 scale. Why am I so stupid today? 40 feet. So the box is at 40 feet, right? So we know our distance, our length is 40 feet, and we know our distance and elevation. So our distance and elevation is 4.8, right? Let me get rid of some stuff. 4.8, and our length is 40. So if you take 4.8, oops, sorry, calculator, 4.8, and you divide it by 40, you get 0.12. And that's going to be a percentage. That's going to be your slope, which is expressed as a percentage. So you're going to move the decimal point over 2 spots, and we have our slope for the horizontal as what just was that? 12%? My brain. Sorry. What did that just say? What was the calculation? 4.8 divided by 40. 12%. You guys paying attention? What was that?
0.12.
Right. 0.12, which is expressed as a percent, is going to be 12% slope going this direction. Okay. So then you can take this same distance in elevation, because the slope on the x-axis, or horizontally right here, is 12%. It's going to be the same for both sides. So you can take the distance in elevation here and just apply it down here. So what was that? 33.3. I should really have a calculator. Let me grab my calculator. I actually have one. One second. Oh wait, I have a phone. Phone's closer. 33.3 minus 28.5. Our distance and elevation, 4.8. Right? No, it was right there. So we're going to apply that to the same thing. We're going to take 34.62 and subtract 4.8 from it. 34 0.62 minus 4.8, 29.82 is this point elevation here. And then the last thing that we need to do, all right, so like this is one of our answers, 12%. This is one of our answers because we're trying to fill in all the missing information. So the last thing we need to figure out is this slope, which is going to be the same method that we did for this slope. So what are we going to do first? Can you tell me? We have our slope formula, dE over L. We know the L. We're trying to figure out the slope.
34.62 minus 33.30.
Right. That is correct. So 34.62 minus 33.3 is 1.32. So we have 1.32 divided by 40, which equals 0.033. And to express that as a percentage, you're going to move the decimal point 2 points over, and this is going to be 3.3% for this slope. And if we're correct, we should be able to take 34.62. We should be able to take this 1.32 and add it to 28.5, and it should give us 29.82, which it does. So that means we did it right. Does that make sense?
Yeah.
First, I forgot to do all this on a new layer, I think. Let me see. Okay, we'll move on to the next one. The next question, right? Would that be helpful if we did the next one over too? Or maybe even this one, because this one's kind of the same thing. Right? Do you think you could figure this one out on your own?
Yeah.
Yeah, right. Do you want to
What
go?
about the third one? Yeah, that one.
Yeah, that one. All right. So let me get rid of this little video preview. Come on. Come on. Oh my God. Okay. So the edge is level all around, right? All four corners are the elevation of 22.5 feet. So every point along this edge is 22.5 feet. So what we're going to be doing is we have the slope for this, and we have the length by scaling this with our scale ruler. We're able to determine that length. So if I take my little 20 scale ruler, so you guys can actually see. Can you guys see my AutoCAD?
Yeah.
Okay. So if you were to take your scale ruler and measure this line, you should come out with 30 feet. We'll round that out to 30. And we're going to do this to all four sides. This one's 15 feet. It's 10 feet. And the bottom one is 25 feet. Okay, let me move these around a little bit. Okay, so the first one's 30 feet. We're going to go back over here so I can draw. This, what's going on here? Why can't I draw? Come on, program. Sorry. Okay, so this length is 30 feet. We know the slope, and we're trying to figure out the distance in elevation, difference in elevation, sorry. So we have 0.02, which is the slope, equals dE over 30. So you're going to multiply 30 times 0.02 to give you the DE, which, does that make sense why you're going to divide up both sides by 30? Or do you want me to kind of,
Yeah, kind of.
let me show you. Let me show you. I need more scratch paper. Hang on. What's going on here? Can I zoom in and make my thing smaller? As small as it. Oh, hang on. Okay. So, what was I doing? 2.02 DE30. Okay, so we have our 0.02 equals, this is too small. Let me fix this. Sorry guys, let's go down here. Okay, 0.02 equals DE over 30. So what we're going to want to do is we're solving for DE. I mean, I preferably, DE might confuse people. We're solving for X is what we're doing, right? Forget the two variables. So in order to get X alone on one side of the equation, we're going to have to get it out of this fraction. And in order to do that, we can multiply this side. Let me fix that. Driving me crazy. So in order to get X by itself, we're going to multiply 30 over 1, which is equal to 30. We're going to do that to both sides, 30 over 1. So over here, the 30s cancel out, and you have X over 1. And over here, 30 over 1 is equal to 30. So you have 30 times 0.02 equals X over 1, or just X. So X equals 30 times 0.02, which our answer there would be, what was it, 30 times 0.02 is 0.6. Yeah, 0.6 equals 0.6. So if we go back over here, we're going down from this point. We take 22.5 and we subtract 0.6 from it. So we have 21.9. This point, that was a horribly crooked line. Can I draw a straight line? Oh no. Whatever, you know what I'm trying to do. 21.9. There you go. So now we know this elevation point. Now we can figure out the difference in elevation, or we know the difference in elevation rather, so we can figure out the slope now for all three of these other lengths. Does that make sense?
Yeah.
Okay. Do you want us to go through the rest of them? Okay.
At least like one more. Yeah.
One more? Okay. Let me double check what these were. We'll do this 25 foot down here. So this one, the length is 25 feet from here to here, right? So this line. The difference in elevation is 0.6. We're trying to solve for the slope. So we have 0.6 as our difference in elevation, divided by 25 feet is our length. So let's plug that into our calculator. 0.6 divided by 25, 0.024. So slope equals 0.024, which equals 2.4% for our slope. I'll go right here. Think. That makes sense?
Yeah. When you do the length, you're doing that by the ruler, right?
Yes. Yeah, you need to have it printed out, and then you need to go up top where it says scale, what the scale is 20, right? Drawn at a
Mhm.
scale of 1 to 20. So you got to go on your engineering scale and go to the 20 side and measure that box out, measure the distance between those 2 points.
Okay. Mm, I got it. Thank you.
No problem.
Wait, Justin, I have a quick question.
Go ahead.
For the DE, I got a little bit confused on that part because I assumed what I had done was subtract 22.5 minus 21.92. But I guess my question is, why do you have 0.6 for your DE?
Because that is the number that we got when we plugged in this 30 feet here and the 2% slope. So a 2% slope at 30 feet.
Mhm.
So you would have 2% times 30. So 0.02 times 30. And that would give you your distance and elevation. That's how much you would rise over 30 feet at 2%.
Oh, okay.
Just multiply 30 times 0.02. And that'll give you your 0.6.
Okay. Thank you.
I think the issue is you're not calculating the slope along the line from 22.5 to the center,
Mhm.
going perpendicular. So the slope is going that way. It's not slanted. So you have to go from that side. You have to go perpendicular in that case.
Mm.
Yeah, you're gonna take your scale ruler. I wish I could kind of like point or point my camera at it, but you're gonna take your scale ruler and measure it just like that.
Yeah. Oh, okay.
That exact line. Yeah.
Okay. Okay. Thank you.
Yeah. You guys can see my AutoCAD, right?
Yeah.
The dimension. Okay. All right. So we'll do this last one because there was confusion about it last night. I clarified.
Before we move on for that one, we only figure out the ones that have the slope on it, right?
Right. You're figuring out, yeah, you're figuring out these 4 or these 3 missing slopes. Yeah.
Okay.
This one's a little bit of a mess, but I can just. Yeah, you're just filling in the 3 missing slopes. That third one. So, okay, so for this 4th one, he wants you to use a parallel slide ruler. So use one of these little guys. If you guys have one, or if you can go and order one on Amazon or something, they're you probably should have one from like first year. But you're going to go perpendicular to the slope that it's showing. And can you guys kind of understand what's being shown here? So what I'm doing is I'm going perpendicular to the slope that's shown, and I'm drawing essentially contour lines. So these lines that are perpendicular to the slope direction, every point along that line is at the same elevation. So if I draw that line, as long as I'm staying perpendicular to the slope direction, if I draw that line on the point that is given to me, every point on that line is 47.65 foot elevation. So I can take that same line, as long as I'm going parallel now, and I can put another one of those lines on the next point that I'm trying to figure out, right? And I know that because I'm perpendicular to the way the direction of the slope, I know that between those 2 lines, I have an 8.3% slope. So now if I measure the distance, if I draw a line perpendicular between those 2 lines that I've drawn, and I measure that line, it's going to give me my length. So now we have two of the components of the slope formula. We have the slope and we have the length. We can figure out the difference in elevation. Does that make sense? Did I lose anyone there? All right, I'm gonna take that as you guys all understand it. So we'll figure it out. We'll do this. 8.3, 16.6. Just roughly sketch this out. Oh my God, no artist. 16.6 feet is our length. Slope is 0.083 equals DE over 16.6. So what we're going to do to get DE by itself is we're going to multiply both sides by 16.6. So 16.6 times 0.083 equals 1.38. We'll round that up to 1.38. So DE equals 1.38. And so we're going to take that 1.38 and we're going to add it, because we're going uphill, we're going to add it to 47.65. 1.38 plus 47.65, 49.03. And we will keep it to 2 decimals because the first point that we were given is to 2 decimals. Oops. So what did I just say? 49.03. 49.03. And then we'll just keep on going, basically. We can go either from that same point, we can measure all the way to the next point with another parallel line, or we can just measure the distance between the first one that we did and the second one. It honestly doesn't matter. Just keep track of which one you're going to add that distance difference in elevation to. So 35.9, do the same thing. We got our 0.0883 equals T. Oh my God, what is going on here? Over 39 point, what was it? 35.9. 0.9. 0.083 times 35.9. 3 times 35.9. 2.98. We'll round that up to. DE 2.98. And now, since we measured from this line to this line, we're going to add that 2.98 to the 47.65, right? So 2.98 plus 47.65 is 50.63. And then just wash and repeat for the last one. I'll go ahead and do it just so you guys can compare your answers, like when you do it on your own. But depending on like little tiny variations, like I obviously didn't hit the points exactly with my measurements. So because we're going to 2 decimal points, our numbers are going to be slightly different, but they should be ballpark the same, right? So the last one's 52.5. 0.5 under DE equals 0.083. Sorry, that's a little messy. 0.083, not any better. So we'll go 52.5 times 0.083 equals 4.36. We're going to round that up to. DE equals 4.36. And so we're going to take that 4.36 and again add it to this guy, which we measured from initially. Again, you can either measure from that first one, or you can measure in between each one. Doesn't matter. Just make sure you're not going to add 4.36 to 50.63, because then that would give you way too much, right? We're going to add that 4.36 back to our 47.65. And we're going to get 4.63 plus, is it 47.65? 52.28. And that should be everything for that question. You're really just looking for those 3-point elevations. Does that make sense, guys? My pretty scratch paper.
Yeah.
Okay. Cool. So, does anyone have any specific questions about any ones that they had problems with? Go back. And look at, what about this one? Were you guys able to figure these out okay?
No.
No. Okay. So I'll show you in AutoCAD, but it's basically going to be the same principle with your ruler and everything. So this is scaled to what it would be, you know, in real life. So if I were to take this measurement and I measure, what I'm trying to do is I'm trying to create a line that is perpendicular, that meets these contours at a right angle and also goes through the point that we're trying to figure out the elevation of. So that looks pretty good. Maybe it's a little off. No, that's wrong. Close enough. Okay, we're going to call it perpendicular. And what we're going to be doing is we need to know the length of that line. Move you over. You would just measure it by hand. You know, draw the line, kind of take a ruler, draw the line as perpendicular as you can get it. Take your scale ruler and measure the length of that line. That line is 23. We're going to just roughly guesstimate. It's instead of 23.2, we'll just call it 23 feet. And then you're also going to draw a line from the point itself to the lower contour. So you can see the numbers on these contour lines. It's 170 here, 176. So we're going lower as we go down. So this is 170, this is 169, and this is 168. So our point A is between 169 and 168. So we're going to go from the lower contour, the 168 contour, and we're going to draw a line from that contour to our point. And that is going to give us, I missed it a little bit. I don't know. It's going to be exactly half. I'll make it not exactly half just for the sake of the problem. 12. Okay, we'll round 12.4 to 12 feet. So we have our main line, it's 23 feet. Our shorter line is 12 feet. We are going to divide 12 by 23. And 12 divided by 23 is 0.52. So you're going to take that 0.52 and add it to the lowest contour, which is 168. So you're gonna, that point is at 168.52 feet of elevation. So we'll do that same thing again for this one. Here we have, we're Wait a second. Are these not at, oh, these are at 2 feet intervals, these contours. Aren't they? Wait a second. 1, 2, 3, 4, 5. Yeah, these contours are at 2 feet intervals. That kind of screws things up. I'm wrong. Just kidding. All right. You're basically going to multiply your answer by 2 though and add it to 168. So that makes it so much less simple to explain though. Let me just do this one. I'll go through it again on this one. We're going to do the same thing. We're going to draw our line as perpendicular as possible between the 2 contours. So this is about what's going on. We're also going to draw our line from the lower contour to our point. We're going to take our measurements. The longer line is 27 feet. The shorter line is 9. I wonder if we should keep a decimal point. Maybe we should. No, we won't. We'll just round it to the nearest whole number for clarity's. I think it'll be fine. So we have 27 and we have 9. Sorry. So we'll do our calc. 9 divided by 27.33333. We're going to take our answer now. So because the contours are 2 feet apart, we're going to multiply the answer that we just got by 2 to get 0.66. Right, oops, sorry, times 2 to get 0.67, right? And that is the number that we're going to add to the lower contour. So this is 160. Contours are every 2 feet, so the next one's 162, to which we're going to add 0.66. So our next point should be 162.66. Where did my text go? Hang on, I lost my. I'll just draw a new one. 162.66 feet. Which makes sense because this point is about 1/3 of the way between these 2 contour lines. And if the contour lines are 2 feet apart, one third of 2 feet is 0.66, right? 2 times 0.3, 0.6. Does that make sense?
Not really.
Not really. Okay, let me do another one. Sorry, let me answer this. Okay, let's keep going. We'll do another one. We can kind of do it again. Let me think. So the reason why we're dividing the shorter length by the longer length is because all we're really doing is getting the proportion. We're getting the ratio of distance from, there are several ways of doing this. You don't, like some people, what they would do is look on their scale ruler and find a scale where from 0 to 1 is a similar length to the distance between 2 contours that you're trying to draw a line for, and they'll just count. If C is on 0.3 or is on 3 out of 10, then it's 0.3 above that next contour. But because the contours aren't 1 feet apart and they're 2 feet apart, you need to, oh man, this is hard to explain. You need to multiply that distance and elevation by 2 because they're not 1 foot apart, these contours. It complicates things by making them 2 feet apart. So basically, like this one here, we can guesstimate, and just for clarity's sake, we'll say it's exactly halfway between these. So we have 170, 168, 166, halfway between 166 and 168 is going to be 167, right? So we know the elevation for this point is 167. Was someone saying something? So the drawing of the lines is really just a way to get kind of the most accuracy. Here, I'll do it again and maybe it'll kind of click. This one's really hard to draw a perpendicular line through. So I'm just gonna say that this is close enough, at least it's perpendicular on the one side. And then we're gonna draw another line from here, from the point itself to the lower contour. And we're using these two measurements to determine the proportion, like kind of like the ratio of distance from that D to the next contour. We're not really getting very technical with it. All we're trying to do is figure out, like, we're trying to make that measurement of those two lines into a 1 out of 10 or an X out of 10 number. And that way we can take that X out of 10 and just add it to the contour. But we can't just add it because every contour is 2 feet apart. So them being 2 feet apart, we just have to double that number that we come up with. So I'm gonna, if the contours were 1 feet apart, then you would just have to divide these two numbers and add it to the lower elevation, and you would have your elevation for that point. But since the contours are 2 feet apart, you have to double the number that you get. So you're going to measure the distance between the contours at the point. So the distance between those two contours that intersects that point D is going to be 26 feet. And the distance from the contour to the point is 22 feet. So you're just going to take 22 and divide it by 26, which turns it into a decimal point out of 1, a kind of a percentage. So this is 84% of the way across that contour. Is basically what we're saying. That's what we're trying to figure out. Is that's a better way of explaining it, actually. That's the reason why we drew those lines and measured them, is because we were trying to figure out the percentage, basically, of how far this point is away from the lower contour. So if the contours were 1 feet apart, you could just take that percentage and directly translate it into a decimal point of elevation. You would just be able to take that 0.84 and add it to that lower elevation. But since the contours are 2 feet apart, you need to multiply that number that we got by 2. So multiply it by 2, we get 1.69, 1.7 we'll call it. And so here we have this line is 160. They go up by 2, so this line's 162. And then we're going to add our 1.7 to 162 to get 163.7. And so that makes sense because the next contour line, if this one's 160, 162, 164, 163.7 is just before 164. Does that make a little more sense now?
Yeah.
Okay. So you're basically, like, even if you wanted to, I don't want to confuse you any further, but think of it as like you're trying to find the proportion, the percentage of how far that thing is away from this first line. It's 85% of that 100%. If the entire distance between the two contours is 100%, it's only 85% of the way there. And you can take that 85%, whether your contours are 5 feet apart or 10 feet apart, you can take that 85% and kind of translate it to however far your contours are apart. That one was a little tough to explain. I apologize for getting into the weeds a bit on that one.
No, but thank you.
Yeah,
So-
no, no. So for like, if you're finding the slope between the points, let's see. So now we have 163.7 and we have 167. And we also want to know, we're going to draw a line between the two. We're going to figure out the length. It's 68. And so, and we're going to figure out the difference in elevation, 167 minus 163.7. So we have 3.3 is our DE and 68 as our length. So it is 3.3 divided by 68. And our slope is going to be 4.85% between these 2 points. Right. Got it, guys? So why don't we take a break for like 5 minutes? We're about halfway through. And we'll meet back at 1:55. Does that sound good, guys? All right.
Thank you.
Yeah.
Okay, cool. All right, I'll be back. Okay. I think I should probably go ahead and do a few more of these. Kind of, I guess I'll do them in AutoCAD because I can draw, you know, and you can actually see what I'm doing. Because I'm not sure if this is clicking for everyone yet. It's kind of a, you know, I'm having a hard time explaining it. So I imagine you guys are having a hard time understanding it. So maybe if I just do a few more, you think that would kind of help? And if anything, you guys can compare your answers, right? And see if you got it. So, okay, let's share. Are we all coming back? I see one thumbs up. Can we do a few more thumbs up? We're all back. Okay. There's at least 4 of you. Cool. Okay. Okay, so we'll do B. And I'm gonna draw my line as perpendicular as I can get it. Looks like something like that, probably. You know, I'll go with that. And then I'm also gonna draw another line. In real life, you just have to draw the one line and take your ruler and you know, measure the one and measure the other. So I'm gonna measure this line. I'm also gonna measure from the lower contour to my point, 24.5, 8.8, and I'll keep the decimals. Gosh, they're so nice and round. You know, might as well keep them. So now I'm going to divide the smaller number by the bigger number. Make sure I'm coming from the lower contour, because if you come from the upper contour, it's going to mess everything up. So I'm going to take 8.8 and I'm going to divide it by 24.5, and that gives me 0.359. Now, that 0.359, again, this is the proportion between these two distances. So since I'm, Sean, are you still there? Is there a different way I can explain this so that I feel like I'm saying the same thing and it's not, and it only makes sense.
Can you show like the work? I think it'll be easier to understand just because
Okay.
I'm more of a visual learner.
Okay, sure. All right, let's see. I don't have that page up in this program yet, but I can basically draw it here. We have our contour, you know, we have our contour, and we have our point, which was kind of in between them. We'll just totally off, but okay. No, let me bring the actual drawing into this program. 1 second. Do. Okay. So let's see here. We're going to work on B. I'm going to take my ruler and I'm going to line it up here. I'm going to draw a line between the contours, kind of perpendicular, that hits that point. Where you draw this line, I can't say it doesn't make a difference, because it will make a difference, but like like this obviously wouldn't be the way you'd draw that line, right? Does that make sense? You wouldn't be like, there's only so many ways to draw this line. You wouldn't do it like this, right? You wouldn't do it like this. No. You wouldn't do it like this either. You know, the one that makes sense in this case would be that kind of line, right? So we have our line here, and we're going to take our scale ruler, which I can't do on this guy here, but we're going to measure from here to here. We're going to measure the total length of this line with our scale ruler, and that is going to turn out to be 24. Your scale ruler is obviously hard to see decimals on, so 24.5. I would round that up to 25. So our total length here. Let me get my ruler back. I kind of like that. Oh, wait a second. I can just move it like this. This is a nice program. Our length here is 25 feet. And then we're also going to measure the distance from the lower contour to our point, which in this case is 8.8 feet, or 9 feet. We'll round up to, because the scale ruler is hard to see. Oh man, what did I just do? Wow, what a fancy program. This program's free too. What's going on here? Okay, so we have our two numbers, 9 feet. Sorry, I forgot to write that here. 9 feet and then 25 feet. So we're going to take our 9, right over here, 9 over 25. 9, which is 9 divided by 25, which is 0.36. 0.36. And now, ooh, I know, this makes sense. So this is the proportion that this contour, that this point is away from this contour. So because these contours aren't 1 feet apart, you're going to multiply this number by however many feet apart they are, which is just 2 in this case. So we're going to take that 0.36 and multiply it by 2. Man, I felt like I was explaining that a different way, but it came out the exact same way. So 0.36 times 2 is 0.72, sorry. So 0.36 times 2 equals 0.72. And so you're going to start with the, oh, of course I forgot to make a new layer on this drawing. Erase all this. It erases the picture. Oh, lordy, lordy. You're going to take 0.72 and you're going to add it to the contour that's below the point that you're starting at. So if we follow these contours, the next one up is 170. And since there's 2 feet between each contour, that lower one is 168. So we're going to add our 0.72 to our 168. Where is, okay, so 168 plus 0.72, 168 plus 0.72 equals 168.72. And that is your point elevation. That is the elevation for this point here. And you would just repeat that for the rest of them. So let me zoom in here. 168.72. Of course, it's not going to fit. Yeah, did that help? I know I basically explained it the same way, but is it kind of starting to click a little bit?
Yeah, I help Marge seeing the actual math.
Right. Okay, so we'll do it again for F. Looks like it could be a little tricky. So I'm going to take my ruler. I'm going to go over here. That looks pretty perpendicular. And I'm going to draw my line. And then I would measure that with my with my ruler, which I don't have one. I can't do that on the screen, so I'm gonna just repeat that. You guys can see AutoCAD, right?
Yeah.
Okay. So this one's gonna be close because they're so close to one another. So it's 6 feet and 2 feet. So our longer length is going to be 6 feet, and the shorter length will be 2 feet. You just divide 2 by 6, which gives you 0.33, 0.33. Can't draw off the paper. But since there's 2 feet between each contour, we need to double this number that we came up with. So it's going to be this 154, the next one's 156, so we're going to take 156, oops, and add the 0.66, this number doubled, 0.66, to give us the 156.66, and that is F. Which makes sense because the next contour would be 158. We got 160 here, so the next one's 2 down, 158, and this point is kind of nowhere near 158, right? It's much closer to 156, the next one down. So that makes sense. It's 156.66. That's where that's what the elevation is at point F. So which ones? I'll get them all for you.
Maybe you can draw them.
Whoa, you were fuzzy, Sean. What was that?
Draw in section. It might help.
Why are you so
Visualize it.
distorted?
I don't know.
Is your microphone like in your shirt or something?
No.
There you go. That sounds better. What did you say? Draw a section?
Draw a section of it. It might help. Just like a super quick one. It's not. Doesn't even have to be at scale.
With that, I mean, it's kind of the same. Like, so you have your hillside, and then you have your
Yeah,
contours.
like one contour and the other contour.
You have your contours here.
So then the idea is pretty much you're just finding your DE first. So in this case, it's just 2. And
Right.
then you're using the L to find the point.
We call it. What numbers were we? What? You should do this really quick, Sean.
I don't have the. Okay, let me convert everything.
It's okay. It's okay. 156 to 158. 156, 158. This is, okay, we'll call it 6 and 2. So the distance, we have the distance here as 6 feet, and we have this distance here as 2 feet. Okay, let me think about this. We're doing things differently now. We still have to do the same exact thing though, Sean.
Yeah, but it will go along with what KG was talking about in other assignments, so it will look more familiar. Maybe.
I just feel silly saying the same thing over and over again.
Well, you just have to keep doing it until, you get it.
I know. I hope I'm helping though, I just
Yeah.
hope-
Hopefully this will help a bit.
it probably does. It probably does. So we're still going to take our 2 feet over 6, which is going to give us 0.33. There's no good way to do that. I guess the only way I can really say is that like it wouldn't make sense if you were to like say, so this is our midpoint here, right? So that would be where 157 would be, contour line, right? If we were to have a contour line here. This point is obviously much more than a third of the way between 156 and 157. So if you just took this 1/3, then that wouldn't make any sense. Because these contours are 2 feet apart, you need to multiply this by 2, giving you the 0.66, which would end up giving you, so you're going to multiply the 0.33 times 2 to give you the 0.66, and then you're going to add that 0.66 to the 156.66, and that makes sense where this is. This point is 2/3 of the way between 156 and 157. Right there. So it's really easy in some senses because all you have to do is divide your shorter measurement by your longer measurement, but it's tricky because if you just take your product and add it to the lower contour, it will be wrong because the contours are 2 feet apart, which is not typical. It's just he's trying to like trick you to keep you on top of things. You have to double this product or the product that you get, the 33, in order to get the 0.66, which is the true difference in elevation between these points. Should have been an artist. Look at that.
It's horrible.
Does that make a little bit more sense, guys? Is it becoming a little bit clearer each time, you think?
Yeah, it's clear for me.
Okay. Do you guys have any other questions then? Do you want me to, you think we're good to move on from this point?
Yeah.
Whoa, Zoom quit. Totally.
Your internet was dying.
It said Zoom unexpected. Are you guys still there?
Internet is dying.
Can you hear me?
Yeah.
Yeah.
It said Zoom crashed, but like
Oh.
everything was still there.
Ignore it.
Weird. Okay. Oh, I don't think it's recording anymore. Yeah, it is. Okay, so I guess we'll do, let's see, what other ones do we have? Does anyone else have any other questions? Do you want to talk about a specific thing? Do we want to go over converting these ratios to percentages? You guys know how to do that?
Can we do that, please?
Yeah, okay. So basically all you're doing is you're going to be dividing 1 by whatever number is on the other side of that ratio, and that's going to give you a percentage, or so if we look at 2 to 1, we're going 2 feet of run for every 1 foot of rise. So if we take 1 and divide it by 2, what does that give us? It gives us 0.5, like 1/2, right? 1 divided by 2 is 0.5. If we move the decimal points over, that's 50%, which makes sense, right? We're going over 2 feet, up 1 foot, that's a 50% slope. And you can also get that answer by dividing 1 by 2. So we can use that same exact method for the rest of them. Let me go back to my math. Yeah, so you can just take for 50 to 1 is just 1 divided by 50, which is like, what, 0.02, I think? 1 divided by 50 is 0.02, so equals to 0.02, which is also known as 2%. So it's the same thing all the way down. 10 to 1 is 1 divided by 10, which equals what? 10%. Right?
0.1, 10%.
Yeah, 1 divided by 10. So that's 10%. 0.1, which equals 10%, because we're going to move the decimal point over 2, right? So there's going to be another 0, an imaginary 0 there, and that gives us 10%. Does that make sense? I'll do the rest, or
Yes, thank you.
yeah. I can only undo so much. I forgot to make a new layer. Let me no, it doesn't matter. Okay, yeah, easy peasy. And then for these guys, it's the same thing, but with inches. So 12 out of 12 equals 100%. 11 out of 12 equals what? It's not 0.83, that's 10 inches. 11 divided by 12, 0.92. So 0.916 repeating, which equals 0.92, which equals 92. Oh, we're not doing percentage, sorry. Just decimal form, 1/100th, 0.92. Because the reason why he's having you do this is because we measure everything in feet, but when we go on computers, everything gets translated to decimal. So most people in our profession will have all of these decimal points memorized. I don't have them memorized yet, but I think 10 inches is 0.83. So if we do 10,
Yeah, it is.
10 divided by 12, yeah. 10 divided by 12 equals 0.83. Equals 0.83 something. So yeah, that's it. 6 divided by 12 is 0.5. 4 divided by 12 is 0.3. 3 divided by 12 is 0.25. And so
It's always going to be divided by 12, right? Because it's 12 inches.
right. Yeah, we're talking about what
What's in a feet, actually?
right,
Yeah.
right. What's the decimal of a foot? So they're all out of 12. So let's see here. Let me look at the other pages. Does everyone here understand how to do these? Do we want to go through a few of these?
Yeah.
Okay. Let me bring this page into my thing really quick. Make a new layer. Okay, So for these guys, we're gonna, oh, I forget. Does anyone remember? I believe KG like told you guys to use a measurement for this, because if you actually scale it, it doesn't come out properly, I want to say, if I remember correctly. Let me see, because I remember last night the students were saying that
Is L equal to 40?
maybe it is. Yeah, that's what it's measuring out as. Maybe we do just use 40. I thought I remember people saying like to use 30 last night for some reason. I'm not sure. We'll go ahead with 40 though, because that's what it's measuring out as. So at 30 scale, which it says, right? So, okay, what we're gonna do is remember how to do these really quick. Okay. I forgot how I did these. Sean, I'm having a brain fart. Are you there?
You just find DE.
Um,
Find DE, measure the length, and then you
And then
want to
division.
find the whole number, like 76.
Right.
77.
Okay. You're right. All right. Okay. So we have 75.4 and we have 76.7. And we're going to be looking for the nearest whole number between the two, which is 76, right? So we're going to find the difference in elevation between 76.7 and 75.4, which is 1.3. 1.3 for our DE. My brain is tired, so I'm going to use a calculator to double check. 1.3. Okay. So now I think we want to figure out our slope, right? Slope equals 1.3, which is our distance and elevation that we just figured out, over our length, which is 40. So 1.3 divided by 40 equals 0.0325. Slope equals 0.0325 or 3.25%. Which that might confuse you. I don't know. You should always just try to keep track that, don't ever plug 3.25 back into your formula. Make sure you always convert the percentage back into a decimal before you actually use it in math. So now we know our slope, 0.0325. We know the distance of elevation, or the difference in elevation between a point that we have and the point that we want, which is 76. So 76 minus 75.4 equals 0.6. So our difference in elevation is 0.6. And now we want to know how far away this point is from this point. So we're solving for L. Okay. So basically, you're going to switch the L and the 0.0325. Right? Yeah.
Yeah, because algebra.
Yeah. L equals, and here, let me actually walk through that so that makes sense. You have your 0. Let me move down here. You have your 0.0325. We have our 0. What was it? God damn it! 0.6, 0.6 over L, and then we want to isolate, we want to get L all by itself. So first what you're going to do is get L out of this fraction. So we're going to multiply both sides by L, or L over 1. So we're going to do L over 1, which equals L. We're going to multiply that by our 0.0325, as well as our 0.6 over L times L over 1. The L's are going to cross cancel, and so what's left over here is now we have L over 1, or just L times 0.0325 equals 0.6 over 1, or just 0.6, right? So now we can get rid of the 0.0325 by dividing it out. So we'll divide this side by 0.0325. Everything we do on this side, we got to do to the other side. So we're going to divide 0.6 by 0.0325, which is going to end up being L equals 0.6 divided by 0.0325, which should be a decently large number. Let's try it out. 0.6 divided by 0.0325 equals 18.46. So we have our L. L equals 18.46. So now we have the distance, 18.46, that the 76 point is away from this 75.4. So you're going to take your ruler, your little scale ruler, and you're going to measure 18.6 or whatever, 19, round it up, because you can't really see decimals. 18.46, round that down to 18. And you're going to go with your little scale ruler. Jesus. Okay, come on. Holy moly. Sorry, guys. And then you're going to measure with your scale ruler from this point 18 feet, or 18 little ticks this way, which of course is less than halfway. So it's actually going to be, you know, somewhere in here probably for 76. Does that make sense? It's a lot of work to find one, but the reason why it's so much work is because once you do every single one of these, you're really going to have it down. You know, you do it 1, 2, 3, 6, 9, 12, 15 times, and you're going to know it really well. So, does that make sense? Do you guys want me to do another one? Because on some of these, like 77 and 79, there's going to be, or on one of these, I think there's 2 points between the two somewhere. This one, so 78, you're going to have 79, and then 80, and then 81. 79, 80, 81, 81.4. Yeah, you're going to have 3 dots between this one. So we should probably just go ahead and do it really quick. Okay, so we have 81.4. Why can't I draw? Let me get my little, you guys are all still there, right? You're awfully quiet.
Yeah.
Okay. So 81.4 minus 78.1. 81.4 minus 78.1. equals 81.4 minus 78.1 equals 3.3. Equals 3.3. So your distance and elevation between these 2 points, sorry, is 3.3. DE equals 3.3. We know our length equals 40. So now we have to figure out the slope, which is just 3.3 divided by 40. Divided by 40, which is 0.0825. Slope, oops, equals 0.0825 or 8.25%. So what you want to do now is you want to figure out how far the first point is. The first point, if we're coming up from 78, will be 79, right? So the distance or the difference in elevation between 78.1 and 79 is going to be 0.9. So now we're going to take our slope, which we have from over here, 0.0825. We're going to take our difference in elevation from 79 minus, and we're going to take this kind of, 79 minus 78.1, right? That's where we're getting this 0.9 from, difference in elevation, and we're going to solve for L. So by multiplying both sides by L, right, we're going to multiply L to get rid of it over here, and then we're going to divide this by the 8.25. So it's going to give us L. The L and the 8.25 or the 0.0825 are literally just switching places. So it's going to be L equals 0.9 equals 0.0825. And that will give us the length to the next point. So 0.9 divided by 0.0825 equals 10.9 or 11. We'll round that up to 11. So you're going to take your scale ruler and you're going to measure 11 feet, however much that's going to be, and you're going to put a point, and that point is going to be 79. Now, to figure out the distance from 79 to 80, which is going to be over here, you're going to do the whole thing over again, right? So you have your 0.0825 slope. It's the same slope because we're dealing with the same slope from this point to this point. So we have our slope. The difference in elevation this time is 1 because we're going from 79 to 80 over here over L, right? We got to figure out that length. So all we're going to do is switch L with the slope. L equals 1 over 0.0825, which is 1 divided by 0.0825, 12. So all you're going to do is take your scale ruler, measure from that 79 point, 12 feet over, and that'll give you your 80 point. And because we're still dealing with the same slope and the point of 81 is before 81.4, you're going to take that same 12 feet that you just went from 79 to 80, and you're going to go from 80 to 81 with that same distance. So you're going to have your 3 points in between these 2 points. Does that make sense?
But in that case, it would be the same answer, right? Because the DE will be still 1 and the S.
Right. Well, so you're not, the point of this exercise is just to actually get these points drawn. And you have to figure out wherever there's a whole number between 2 of these crosses. So you have 81.4 here and 81.6 here. There's no whole numbers between those. So there's not going to be any points between these 2 points. But if we go between 79.2 and 81.6, you go 79, 80, 80, 81, 81.6. So there's going to be 2 points between these two. And the point of this exercise is to find all of these points between these crosses, and then you're going to end up connecting them. You're going to end up with an 80 over here, and you're going to end up with an 80 right here, and you're going to end up with another 80 over here, and you're going to take a line and you're going to connect those 3 80s. And you're going to do that for every single one. You're going to get a 79 and a 78, a 79 over here, right? A 78 over here. You're going to connect your 79 to your 79. And it's going to go like something like this, something like this. And I can show you what it actually turns out being is basically something like this. Does that help? Clear as mud.
Yeah.
Okay. All right. Well, we're over time for today. I'm going to be sending out more sessions for Saturday, I believe. I don't think we're doing anything tomorrow. And then next Tuesday. And we're going to keep scheduling them. So if you guys need more help, I'll put my email too in the chat if you guys want to email me to like keep going over things and clarifying them. Let me know. Give me an email and I'll be happy to help you out. There's my email. Maybe Sean can put his. I can't think of it off the top of my head, but he will respond to your emails as well. Let us know if you have any questions. And sign on next time if you guys need more help. Hopefully this was helpful. Thank you guys for coming.
Thank you.
Alrighty, guys. We'll see you around next time.
Thank you.
Yep.